Guys, welcome back to my channels, and today's it's academic vlog. So in this videos I'm gonna show you what I have learned in physics class, and yeah, today's is gonna be nuclear reactions. So I have learned of fissions, fusions, alpha decay, beta decay, and gamma decay. So let's start with the first reactions, which is fissions. So all requires the neutron to get start. Okay, so the Mr. Neutron here is gonna shoot into a nuclei, which is the uranium 235 in a stable state. But when the neutron shoot in and combine, it turned the uranium 235 to uranium 236, and from the stable state to unstable state of a nuclei. So when the nuclei turns to an unstable state, it split to the two daughters nuclei and some neutrons. Also, it's create some energies and heat. So the neutron, proton, and atomic number of the fissions is the same. Let's start with the second one's fissions. So opposite with the fissions, where where the larger atom try to split out to the smaller ones, where we have the two smaller atoms combine into the larger one. Okay, so here we have the deuteriums and tritiums try to combine it together. So here we have the protons that have the same charge with each other, so it's required a high energy to combine it together. Once two atoms occur, it releases the high energy, which is the high heat and high temperatures. And from now, the where it's released the high energy, the hydrogen atoms change from gas to plasma, and where we call it matter energy conversion. So next it's alpha decay. This reactions happens when an unstable nuclei try to decay in to balance it. So the number in these reactions, the number of protons and neutron, it may change, but the atomic number, which is the total of these, is still the same. So this process requires an unstable nuclei. Well, it must be unstable because to make the alpha decay happens. So during the alpha decay, the nuclei gonna give off alpha particle, which is the have a symbol here, and you can say it's a heliums. This heliums have the mass number it's 4, and atomic number is 2, and also it have 2 proton and 2 neutron. So because the particle, alpha particle, it's such a heliums here specific, so the number of proton, neutron, and atomic mass number, it does change. So it's the nuclei will lose 2 neutron, 2 proton, also lost 4 mass number, and it will lose 2 atomic mass number. So for example, you can see here, this is the uranium's 238, and so it is that alpha decay when the uranium 238 try to decay, to take a part off to balance it. So it's when take a particle, it would take a alpha particle out, which is the helium 42 and 4, and also we can know the answer. It thorium's 234. So it's gonna be 238 minus 4. So this is the result, and the 992, which is an atomic number, got a minus 2. So the result is 90. So based on the mass number and atomic number, you minus it, and you got a result, which is the other elements. So when it gave off a part of the nuclei, an atom, it will release an energy, which is form of the heat, or you can say kinetic energy. Also, alpha particles are emitted. Bad decay. So I know that all decays are similar from each other because they always get off apart and decay and try to balance the nuclei. So yeah, well, the requirements of these reactions, it's unstable nuclei. However, in bare decay reaction, they got two reactions and two decays. So first, it's beta minus decay, which is the neutron, blue one, and turn into the proton. So you can see there's two blue and here's the two yellow. So it turned to a lemon and plus with the electrons. And the beta plus decay, it opposite ways, which is the protons turn into a neutrons and plus with a positron. So well, yeah, the electron here and plus the electrons and the positrons, it's known as a beta particle, and they are emitted. Also, there's two different ways. So the neutron, proton, and atomic number, it's quite different. In a beta minus decay, the neutrons got -1 here, and the proton add 1 more, and also the atomic number of it, it's +1 more. And also in a beta plus decay, the neutron here will +1, the proton gonna lose 1, and atomic numbers gonna be -1. And I think the energy release come from the atom that hold each other will be in as just a particle, and also when the energy released, it's gonna release the energy in the form of heat, which is kinetic energy. And I think the energy release come from the atom that hold each other will be in as just a particle, and also when the energy released, it's gonna release the energy in the form of heat, which is kinetic energy. The final one, it's the gamma decay. So the gamma decay happens after the alpha and beta decays. Once the nuclei still in unstable form, it's gonna give up, split to the daughter nuclear and its gamma ray to balance the nuclei again. The energies take from the previous decays that it's already happened into this one, so it turns the nuclear to the daughter nuclear valence and express some gamma ray. Fun fact, nuclear energy released in the nuclear fissions and fusions, it's 100 times as large as a chemical reactions, which is the combustion process. Whoa! Imagines how atomic bomb destroy a cities compared to a chemical combustions in a natural process. So, in conclusions, I found out fissions, it's when big atoms try to split into two other atoms, which is smaller. And fusions, it's two smaller atoms trying to combine into a big one. And all the decays we have is a process that nuclei try to decay and balance it, turn it from unstable state to a stable state. So bye, thanks for watching.